sing a happy song together, and we'll all be a happy family.
Well, hi, welcome back to the channel. So, looking at this Theremin, what I've decided is to go through their description from the article of how this thing works, and it may be of interest to some people, but it also may help in trying to establish why the volume antenna doesn't seem to be doing much at the moment. So first we'll go through their description, and we'll step by step we'll look at this. Transistors Q1 and Q2 are the variable and fixed pitch oscillators respectively. So if we go over to here, there's Q1, and that therefore is the variable oscillator with the pitch antenna going to the collector there. And Q2 is down here, so that's the fixed one with L2, and this one has L1, which is mounted on the side of the Theremin. So that's the pitch side, and Q4 serves as the volume oscillator. So here's Q4, it's a similar arrangement, and there's the volume antenna, and it works with L3. So all this area here, that's the volume oscillator. Essentially similar circuits are used in all three oscillators. So only one, Q1, will be described here. So we're looking at this area. Base bias is established by resistor voltage divider R1 and R2. Fairly straightforward. So there's your base biasing. With the former, that's R1, bypassed for RF by C3. C3. Resistor R3 serves as the emitter output. There's R3. The basic operating frequency is determined by the tuned circuit of L1 and a combination of C1 and C2. L1 and C1 and C2. In the case of Q1 and Q4, the volume one, their tuned circuits are also connected to external antennas, or trowels. When these antennas are loaded due to body capacitance, the presence of a hand near the antenna, this load is reflected to the tuned circuits as a capacitive change, which in turn alters the frequency of oscillation. Because Q2's circuit uses no antenna, its frequency remains constant at all times. So obviously it's down here. We haven't got the antenna stuck on there, so this should stay much the same. In operation, Q1's RF output signal is coupled to mixer amplifier Q3 down here via coupling capacitor C5, while Q2's signal is coupled to Q3 via C10. So there's C10. So we've got C5 coming down here and C10 coming to there. Okay. If these two oscillators, Q1 and Q2, are at the same frequency, then there will be no resultant beat present at the collector of Q3. Yeah, so if these are matched, then at this point here, summing these two together, there'll be no beat frequency. In other words, both of these will be in tune with each other. However, since Q1's frequency is determined by how close the operator's hand is to the pitch antenna, the resultant beat frequency will vary as the distance between the hand and antenna varies. Because the mixing action of Q3 produces both RF and audio beats, capacitor C12, where's C12? There's C12. C12 is used to bypass the RF components and prevent them from appearing at the collector of Q3. The resultant audio beat is passed via the volume control to the field effect transistor output stage Q7. So there we have signal coming out of here into Q7 and therefore the final output. Oscillator Q4, the volume oscillator, like the pitch oscillator Q1, has its frequency of oscillation determined by the amount of hand capacitance near its antenna. The RF signal at the collector is coupled via C20. So let's find C20, it's there. To another tuned circuit consisting of L4 and C22. So here's L4 and C22. The RF signal across this second tuned circuit is rectified by diode D1 and applied to the base of DC amplifier Q5. Thus, the DC voltage level present at the collector of Q5 is a function of the amount of RF present on L4 and C22. This level is at its maximum when the L4C22 tuned circuit is at the same frequency as the Q4 collector tuned circuit. In practice, however, the frequency of Q4's tuned circuit is made to be slightly higher than the L4C22 frequency. As a result, very little DC signal is passed to the base of Q5. This means that the voltage at the collector of Q5 is at a maximum. If the frequency of Q4's tuned circuit is reduced when a hand is placed near the volume antenna, the base current applied to Q5 increases, causing the collector voltage to drop. The unique volume control consists of field effect transistor Q6 connected in shunt with the audio signal flow. So the audio signal, as we've shown earlier, was coming through here, and this is shunted across it. The audio signal at the collector of Q3 passes through the DC blocking capacitor C13 and is also isolated for DC from Q7 by C14. Resistor R13, where's R13? There's R13 in the signal line. Right. Resistor R13 and field effect transistor Q6 are arranged as a voltage divider. If the gate voltage of Q6 is highly positive, then the field effect transistor acts as a low resistance between R13 and ground, greatly reducing the signal level allowed to pass to Q7. As the gate of Q6 gets less positive, the effective resistance of Q6 increases and the level of audio signal to Q7 increases. The voltage at the collector of DC amplifier Q5, we're up here again now, is connected to the gate of Q6. So it comes down here to gate of Q6. As this voltage level is determined by the frequency of Q4, the operator can readily adjust the output volume by changing his hand capacitance to the volume antenna. The variable pitch, variable volume audio signal is coupled to an external audio amplifier via Q7. An FET is used for Q7 because its very high input impedance, a couple of megohms, will not affect the operation of field effect transistor Q6. If desired, the source resistor of Q7 can be changed to a smaller or to a similar valued potentiometer. So yes, you could actually make it adjustable by making R16 adjustable. So that's what they've said about how the system should work. So that's the beginning point, really. Then I can start trying to look at the various voltage levels, see if this voltage is actually varying here when I move this. Is this frequency actually changing? So yeah, there's possible ideas there. But any comments on this are welcome, and I hope this is of interest. It's not the usual practical demonstration that I do. It's rather more an academic one, but that's how the article described it, and there's the circuit diagram. So yeah, any comments please, and that's this stage really complete. Then we'll start looking at whether I can get this volume side working as well. The other thing I've got to do, of course, is make the case instrument itself. So there we go. And as for that, we will conclude and we'll catch you on the next one. Bye for now.
Sing the happy song together, and we'll all be a happy family.